Peter, I've been pondering how exactly do brain-computer interfaces work? I mean, how does a machine interpret our thoughts and turn them into actions? It sounds like science fiction, but I assume there's some real science behind it.
Well, Stewie, it's actually pretty fascinating. Basically, brain-computer interfaces, or BCIs, record electrical signals from your brain, mostly from neurons firing, and translate those signals into commands that a computer or machine can understand. There are two main types: invasive, where electrodes are implanted directly into the brain tissue, and non-invasive, like EEG caps, that pick up signals from the scalp.
Wait, so you're telling me they can actually interpret specific thoughts? How precise can this get? Can it distinguish between, say, thinking about a cup versus thinking about walking?
Good question. The precision depends on the technology and the part of the brain being monitored. For example, in motor cortex BCIs, they can detect signals related to movement intentions. So yes, thinking about moving your hand might activate certain neurons, and the system learns to recognize those patterns. Over time, with machine learning algorithms, BCAs can become quite accurate, enough to control prosthetic limbs or even type words just by thinking.
That's astonishing. But how does the machine learn what each neural pattern means? Is it like training a dog?
In a way, yes, the system is trained with a bunch of data, say the person thinking about moving their fingers, and the algorithm identifies consistent patterns. It uses supervised learning where the computer gets feedback, so it improves its decoding over sessions. It's similar to how speech recognition works, but instead of recognizing words on a screen, it recognizes neural signatures.
I see. And what about non-invasive methods? Are they less accurate because they're not implanted?
Exactly. ED-based BCIs are safer since they're just caps with sensors, but they have lower resolution. The signals are weaker and get mixed with noise from other brain activity and even muscle movements. That's why invasive BCIs tend to be more precise, but they come with surgical risks. Researchers are working on improving non-invasive tech, though, so someday you might just think and control devices directly from your brain without risking surgery.
This is truly remarkable. Peter, I had no idea the science had progressed so far. I mean, I knew about basic neural signals, but the level of decoding and control is just astonishing.
Yeah, it's like giving your brain a direct Wi-Fi connection to machines. We're getting closer to having mind-controlled gadgets, even potential treatments for paralysis or neurological disorders. It's the future, Stewie.